Guys, the last lesson we talked about probability from two-way tables, so we're going to kind of move past the two-way tables in any visual and go more into just word problems and how do I figure out probability given a certain situation. So today we're going to talk about tree diagrams and how we can use those to find probabilities. So a tree diagram can be used to find the number of possible outcomes of more than one event. Okay, so instead of just saying, hey, I'm going to pick this from a drawer, what's the probability of choosing a red? You're actually going to be doing two different things or three different things today. So you could be picking from a type of shirt, a type of short, and a type of shoes. And so it's going to change the number of possible outcomes that we have because we can combine them in different ways. So to draw a tree diagram, you're going to start with your first event and write the possibilities of that event. And then you branch off from that event with the possibilities of the next one and so on. Okay, so we'll start with an example, and we're only going to do two. So I'll show you how to draw the tree diagram, and then we'll use the diagram to answer some questions. So Miguel is going to choose an outfit. He has two different colored t-shirts to choose from, blue or green, two different colored shorts, gray or khaki, and three different pairs of shoes, Nike, Converse, or Vans. So how many different outfits can he create? And the reason why we need this is because if we find the probability, we need to know the number of possible outcomes or the number of possible outfits. So we have to use our tree diagram to figure out, well, how many ways can I put these things together? Okay, so you start with your first choice. So his first choice is t-shirt. So he either has a blue or a green t-shirt. And you can abbreviate because it's just for you. It's just a good visual. And then once he chooses his t-shirt, now he has shorts. He can either choose gray or khaki. So we're going to branch off of that first one and put gray or khaki. And then from here, I'm going to put GR since this one was green. Okay. Oh, let me just write gray. Okay. So gray or khaki. And then once he chooses that, then he can choose three different pairs of shoes. Now you need to branch off of each section here. So from the gray, he can choose Nike, Converse, or Vans. Okay, from the khaki, he can choose Nike, Converse, or Vans. Same thing here. Okay, and Nike, Converse, or Vans. Okay, so when you're done with your tree diagram, you should be able to see every possible outcome. And if it helps, you can write them out as well if you wanted. I'm just going to show you a few so you can see the different possible outfits. So the first one is just this full branch together. So that would be a blue shirt, gray shorts, and Nike shoes. Okay, that's one outcome. He could do a blue shirt, a gray shirt, and Converse shoes. Okay, blue, gray, and Vans. Okay, and then he would do blue, khaki, and Nike. Okay, and you can see what I'm doing here. I'm not going to list them all out because you technically have them listed here. So the number of possible outfits, we would have 1, 2, 3, 4, 5, 6. Okay, following those branches, so there's 6 there. 7, 8, 9, 10, 11, 12. Okay, so there are 12 possible outfits that he could create with those choices. Okay, so that's letter B. How many outfits are possible? So when we're doing our probability, this is going to be what we need to divide by. Okay, so let's answer some questions based on our diagram. So if he randomly selects an outfit, what's the probability he chooses a blue shirt, gray shorts, and Nike shoes? So we need to find blue shirt, gray shorts, and Nike shoes. So blue shirt, gray shorts, Nike shoes. So that is the only time that's written down. There's not another section over here because that's a gray shirt or green shirt. So blue, gray, Nike. He has one of those in my tree diagram out of the 12 possible outcomes. Okay, so his probability would be 1 out of 12. So if he randomly selects an outfit, what's the probability he chooses an outfit with Converse shoes? So we need to figure out how many outfits contain Converse shoes. Okay, well, I see a C right there, so there's 1. Okay, I see another C there, so there's 2. Over here, okay, there's 3 and 4. So there are 4 outfits out of 12 that have Converse shoes. Or if you simplify that, that would be 1/3. Okay, and then if he randomly selects an outfit, what's the probability he chooses an outfit with a green shirt and khaki shorts? Okay, so we need a green shirt, so we're going to be over here, and khaki shorts. So sometimes you may see that as 1, but you got to go all the way down. So green khaki Nike, that's 1. Green khaki Converse, that's 2. Green khaki Vans, that's 3. So all 3 of these have a green shirt and khaki shorts. Okay, so there are 3 outcomes out of the 12, which simplifies to 1/4. Okay, so on the questions, make sure you draw your tree diagram. Some of them will be drawn for you, and then you just kind of use those to figure out how many out of those possible outcomes. Okay, so let's try one more. Okay, and we'll do another tree diagram, and then I'm going to show you a kind of a shortcut to figure out the number of outcomes. So Sarah's making a sandwich. She has 2 breads, sourdough and wheat bread. So I'm going to separate those. Okay, and then she has 2 meat options. So we're going to branch off and do ham and turkey. And then 2 cheese options, Swiss and American. So we need to branch off of everything. Okay, so draw a tree diagram to show all the possible sandwiches she can create. So now we've got those. So she could do sourdough, ham, and Swiss, sourdough, ham, and American, sourdough, turkey, and Swiss, okay, and so on. So how many possible outcomes are there? So 1, 2, 3, 4 right here, and then 1, 2, 3, 4 right here. So 4 and 4, so we have 8 total. So she creates a sandwich. What's the probability she uses wheat bread? So how many of these 8 have wheat bread? So all of them over here. So that's 1, 2, 3, 4. So 4 out of 8, or 1/2 if we simplify. What's the probability she'll use sourdough and wheat bread? Well, here's sourdough, here's wheat bread. Can she have both of those at the same time? Are there any sandwiches that have sourdough and wheat? No. Okay, she's choosing one or the other. So there's actually 0 out of 8, or a 0 probability. Okay, what's the probability she'll use wheat, ham, and Swiss? So we have wheat, ham, and Swiss right there. Okay, so that's 1. Do we see any other wheat, ham, and Swiss? No. So that's the only one we have. So 1 out of the 8 possibilities. Okay, and then what's the probability she'll use wheat and ham? So we can do wheat, ham, and Swiss, that's 1. Or we can do wheat, ham, and American, that's 2. So there's 2 ways to use wheat and ham. So 2 out of 8, which simplifies to 1/4. Okay, so just use your visual. If you need to write them out instead, if that helps a little bit better, there shouldn't be too many possibilities, but sometimes that gets tedious, so the tree diagram will help you. Okay, and then our last thing is just kind of a shortcut to finding the number of possible outcomes. Because if you have a lot of things to choose from or a lot of events, you'll be making huge tree diagrams, and we don't want to do this. So this is called the fundamental counting principle. So we can use this to find the number of possible outcomes, especially if there are a large number of them. This counting principle states that to find the number of possible outcomes, you're going to multiply, okay, that's the key, the number of outcomes for each event together, okay? So Adelia is doing an inventory of their ingredients. They have 8 different types of meat, 6 different types of bread, and 4 different types of cheeses. So how many types of sandwiches could you create? So think about if you were to try to make a tree diagram, we would have to draw out 8 different meats, okay, branch off of those with 6 different breads, and branch off of those with 4 different cheeses. Okay, so that's going to get really big really fast. So our counting principle basically says that if we multiply our number of different choices together, then we can figure out how many possible outcomes we could have. Okay, so if I have 8 different types of meat, and then I have to multiply that by my 6 different types of bread, and then by my 4 different types of cheeses. So 8 times 6 times 4, and that gives me 192, okay, possible different types of sandwiches. We don't need to know what they are at this point. It's just how many different types is what we're looking for. Okay, so Mary's choosing ingredients for ice cream. She has 2 different cones she can use, so that's my first choice. Waffle or sugar, 3 different ice creams, chocolate chip, vanilla, or strawberry, and then 2 different toppings, sprinkles or chocolate drizzle. So how many different types of ice creams could she create? Okay, and it's not asking us to find what they are, it's just how many. So look at our different choices. So we have 2 different cones. That's my first choice. My second choice, I'm choosing between 3 different ice creams. And then my last choice, I'm choosing between 2 different toppings. So I need to do 2 times 3 times 2. So 2 times 3 is 6. 6 times 2 is 12. So there would be 12 possible ice creams that she could create. Okay, and if you go back to the top, and I'll just show you this one real quick, you can see how this would work here. So we had 2 breads. Okay, we had 2 different meats. And then we had 2 different cheeses. So if I multiply 2 times 2, that's 4. And then multiply that by 2, that gives me 8, which is the same thing we got when we created our tree diagram. Okay, so this is just a shortcut, especially when there's large numbers, that you don't have to make a tree diagram with 192 branches on it, because that would take forever. So use that. I tried to give you a hint on the quizzes where it said find the possible events. I would say use the fundamental counting principle, but you can always use that as well. Make sure you look at that schedule that I posted on the document. It's on page 2 to kind of separate when to work on which assignments. I know it's overwhelming to have 7 classes and try to figure out when to do what. So look at your Monday, see what classes should have their stuff posted on Monday, or if they have a live Google Meet, it will be during that time. And then look at your Tuesday and see which classes should have their stuff posted on Tuesday. And then the same thing for Wednesday and Thursday. So that will help you separate your assignments a little bit more to help us get through the rest of this digital learning. So hope you guys are doing well, and I'll see you next time.